In our last lesson, we talked about multiplying monomials by polynomials, and today we're just going to talk about multiplying polynomials. In each of the first two cases, we're multiplying a binomial by a binomial, and really what we need to do here is simply do, if you will, a double distributive property. So we need to multiply each term in one form by each term in another. So what I'm going to do is I'm going to draw little distributions from the y to both the y and the -4, and then the 8 to the -4. So when I do that, I've made sure I multiply each term in the left by each term in the right. Y times y is y squared. Y times -4 is -4y. 8 times y is 8y. And 8 times -4 is -32. I combine like terms and I get y squared plus 4y minus 32. And that's my multiplication. Now, when I do multiplications of binomials times binomials, there's a mnemonic device that we call FOIL, which means when I'm multiplying only a binomial times a binomial, this works. You take and multiply the first terms by the outer terms, by the inner terms, by the last terms. First, outer, inner, last. And I'll refer to FOIL quite often during this lesson. So again, two binomial terms, we're going to FOIL first, outer, inner, last. Do those multiplications, get 2x squared plus 12x plus x plus 6, combine like terms, 2x squared plus 13x plus 6, and simplified. Again, here's the FOIL method outlined once again. I take the first terms, multiply them, second terms, multiply them, inner terms, outer terms, and we're all done. So next we're going to look at a little application of this. We want to find the area of the rectangle, and the area means multiplying base times height, or length times width, however you want to describe it. In each case I have a binomial. 3x plus 2 would have to be multiplied by 4x plus 1. I'll FOIL that. Get 12x squared plus 3x plus 8x plus 2. Combine like terms, 12x squared plus 11x plus 2. And that's an expression for the area. Now, in this case, it's not a binomial times a binomial, so you're not necessarily able to FOIL because there's not 4 terms. But what we do is, again, we distribute every term in the left to every term in the right. So I'll have 3 distributions with the 3a and 3 distributions with the 4. So in this sense, I get 3a cubed minus 36a squared plus 3a plus 4a squared minus 48a plus 4. And then I have to combine all my like terms. There's no cube term, so that's 3a cubed. Got a couple of squared terms. That gets me -32a squared. Couple of a terms. That's -45a, and a constant of 4. In this case, again, we're going to have to multiply every term in the left times every term in the right. So I'm going to do this methodically. I'll go 2b times b squared is 2b to the 4th since I'm adding powers. 2b times 3, or 2b squared times 3b is 6 b cubed. 2b squared times negative 1 is negative 2b squared. Then I'll take and multiply the 7b times everything. I have positive 7b cubed plus 21b squared minus 7b. And finally, the 9 gets multiplied to everything, and I get 9b squared plus 27b minus 9. And then we clean it up by combining all like terms. 2b to the fourth. There's a cube and another cube, which gets me 13b cubed squared, squared, and squared. Negative 2 plus 21 plus 9. It's looking like 28b squared. B terms give me a 20b and then minus your constant. Now we've got a word problem. We're going to think of a whole number. We don't know what that whole number is, so we're going to call it x. We'll subtract 2 from it and write the number down. Take the original number x and add 2 and write that number down. Then we're going to find the product of these two. So let's go ahead and FOIL that. X squared plus 2x minus 2x minus 4, which gives me x squared minus 4, since the 2x and negative 2x go away. Subtract the square of the original number from that new product. X squared minus x squared is 0. I'm left with negative 4, and the result is always negative 4. And we proved it as we went through the problem. So in this problem, what we're going to do is be writing expressions for areas in the figure. And what this person's doing is we're constructing a painting, and then around that painting we're going to make a frame, and that frame is going to be even around each side. In fact, it's going to be 2 feet on either side, so a rather big frame. Then it says the length is 5 more than the width, or 5 longer than the width. Let's call this the width and call this the length. But if we're going to write an expression for this, we want to use one variable. So I'm going to call the width x because the length is being compared to the width. So call this x, and this is x plus 5. And what we want to do is we want to do 2 things. We want to write an expression for the area of this mural, so of the picture itself. Well, area is length times width. So A. Length times width is x times x plus 5. We can simply multiply those, which is x squared plus 5x. And B, they want an expression for the area of the frame only. Well, the frame is the area of the whole minus the area of the picture. That's equal to the area of the frame. So I need the area of the whole thing. Now, if you look at this, it's x width right here, but I have 2 feet here and 2 feet here. So the whole, if you will, is x plus 4. And then this whole, if this is the length, it's x plus 5, but then there's 2 here and 2 here. That's x plus 9. So the area of the whole is x plus 4 times x plus 9. And we have to subtract off the area of the picture. We already did that. The area of the picture is just x squared plus 5x. And that will give me the area of the frame. I'm going to need to FOIL this. So it's x squared plus 9x plus 4x plus 36. Then I'm going to subtract this next term, which means subtracting each term inside or multiplying by that imaginary -1 to both, which gets me a minus x squared and a minus 5x. So we have the x squareds going away. We have 9x, 4x, and -5x, which gets me an 8x plus 36. And 8x plus 36 is the area of the frame moment.